All right, guys, so this is section 8.2, and in 8.2 we're going to talk about the angle-angle similarity theorem. So some of you are like, oh, this sounds similar to angle, side, angle, and stuff like that. Well, it is the same, except these are similarity theorems, not congruence theorems. Okay, so angle-angle similarity theorem tells us that if we know of two figures, and we have two corresponding angles that are congruent, then they have to be similar. Okay, well, let's think about this. Why wouldn't you need three angles congruent? Remember when we did the third angles theorem, it said that if two angles of one triangle are congruent to two angles of another triangle, then the third angles would also be congruent? Well, that's the reason. Because by default, we know all three of these add to 180. So by default, this would have to be congruent to this. And therefore, we know that any triangle, if all three angles are congruent, then they have to be similar. All right, so let's look at example 1 here. It says determine whether the triangles are similar. If they are, write a similar statement, explain your reasoning. All right, so I have two triangles here, okay? I want to find the measure of this triangle, or of this angle. Now I know this and this are right angles, so those are congruent. But I need to know that at least two of the three angles are congruent. Okay, so I could say, well, 26 plus 90 plus angle E has to equal 180. Okay, and if I do simple math, then I would get angle E is in fact 64 degrees. So I can say, yes, they are similar. Yes, by the angle-angle similarity theorem. And when I say angle-angle, I know we have the two 90-degree angles, and then I know we have the two 64-degree angles. Okay, and then to write a similarity statement, I can say that triangle, I don't know, CDE is similar to triangle. Well, now angle C is the 26-degree angle, so this would be the 26-degree angle, so okay. D is the right angle, so I'd have to have the right angle here. And then 64 is E, so H is 64. Remember, the order of this one doesn't matter so long as the order of the second matches it. All right, so let's look at this proof here. We want to prove that the two triangles are similar. Okay, so it's given to me that angle ABE is congruent to angle ACD. That's given. Okay, so this angle here and this angle here. Now, if I look at this, guys, don't both of these triangles share angle A? So I have this triangle here and this triangle here. They share angle A. So I can say that angle A is congruent to angle A by the reflexive property. Okay, well guys, here's an angle, here's an angle. All I need are two angles. I have my two angles, so I can say that triangle ABE is similar to triangle ACD by the angle-angle similarity theorem. All right, I want you to go ahead and try this proof on your own. Keep in mind that there are several different ways you can do this proof, but go ahead and do it on your own and then we'll go over it. All right, so this is what I got. What is given is that these two sides here are parallel. And then I pulled out of there that T and R are congruent, and then S and U are congruent, and that gave me angle-angle similarity theorem. Some of you probably pulled out that vertical angles are congruent, and then one of these two other pairs, which is perfectly fine as well. But either way you have it, you only have to prove two of the angles are congruent, and then you'd prove it by the angle-angle similarity theorem. All right, I want you to try to do example 3 on your own. Look at example 1 as a reference because example 1 was kind of similar, and then we'll go over it. All right, on this one you do have to do just a tiny bit of math, and I did it on this right triangle. You could have done it on the left too. But I found that this angle D up here, probably shouldn't have written angle D, I probably should have written angle EDF, is 32 degrees, just because I know all three angles of a triangle have to add to 180. We also know that this angle DFE is a right angle because they're a linear pair. And so by doing that, I found the 32 and the 32 and then the 90 and the 90, and by angle similarity theorem, I found that they are similar. Now, I wrote a similarity statement. I also realized there was one right here, which is the same thing, but you could have also written it a different way. You could have written that angle, I don't know, EDF is similar to triangle DFC. EDF. Yes. All right, let's look at this. We know that this here is a right angle because these two are linear pair and linear pair is supplementary. So if one's 90, the other has to be 90. And then I did just a tiny bit of math and I found that this angle up here, I probably shouldn't have called it angle D. I probably should have called it angle FDE. But that's 32 degrees. And then I could stop from there because I noticed this 32 degrees was the same as this 32 degrees. And then I have two 90-degree angles. So I don't even have to find the measure of this angle here. It doesn't matter because by the angle similarity theorem, I know the two triangles are congruent. Now here's one similarity statement here. Remember, you can write them in several different ways. Here's my other one here. And the way I like to write them is if I know the measure of the angles, I like to write them just so I can make sure they have them in the same order. If this goes 58, 90, 32, then this has to be 58, F is 90, C is 32. All right, let's look at example 4. It says a flagpole casts a shadow that is 50 foot long. Okay, so the flag is 50 foot long. At the same time, a woman standing nearby, 5 foot 4 inches, casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Clearly, it's taller than this building, so we are not going to grab a tape measure and just measure this. So what I'm going to do first is I'm going to go ahead and I'm going to draw an image. Okay, so this is the flagpole here, and it is 50 feet. Okay, and here's my woman, I don't know, right here. Don't make fun of my stick, people. I'm not an artist. Here's my woman. She is 5 foot 4 inches, and she cast a 40-inch long shadow. Okay. Now, the first thing I notice is we have feet. We have feet in inches, and we have inches. So we are all over the place. So we first need to make all these the same measurement, convert them. So I think it'll be easier to do inches. Okay, so 50 feet, so 50 times 12 gives me, this is 600 inches. Okay, and then 5 foot 4 inches, so 5 times 12 is 60 plus the 4, this is 64 inches. Okay, now we know people stand straight up and down, otherwise they would topple over. So that's a 90 degrees, we know this is a 90 degrees. We know that there's a sun up here that's beating down the same as it is here. So we know that this angle here and this angle here are congruent. Okay, so we have an angle similarity theorem. I'm going to go ahead and mark these a little clear. So this is 40 inches. This is 64 inches. And then this is 600 inches. Okay, so I have two similar triangles, so I can set a proportion. I can say this is to this, so 600 is to 64, as this whole thing, which I don't know, I'm going to call X. That's what I want to find, is the shadow of the flagpole, as X is to 40. Okay, then I can do some math. Okay, so I can say 64X equals 600 times 40. And 600 times 40 is 24,000. Divide both sides by 64. I get 375. Now remember, that is inches. Okay, I want to know how tall the flagpole is to the nearest foot. Okay, so I'm going to divide this by 12, because there's 12 inches in a foot, and I get 31.25, or 31 1/4 foot. Or it says round, oh, it doesn't say round. How tall is the flagpole? To the nearest foot, so that's rounding. So 31 foot tall. All right, I want you to go ahead and do example 5 on your own. Use example 4 as a reference. They're very, very similar, but go ahead and do that, and then we'll go over it. All right, so I've gone and I've drawn a little diagram. Like I said, my art skills are a little lacking. And if I draw it without the crazy stuff, I have this triangle, and I'm going to go ahead and draw them separately. Why not? Okay, so this is the tree. This is the person. And this is the tree shadow, and this is the person's shadow. Okay, so we know that this angle and this angle, the angle that the sun's beating down on them, is the same, and then we know they're both standing upright, so these are the same. So these are similar by the angle similarity theorem. So write a proportion showing how we could find the height of the tree. All right, so we can say the tree height, just T, so tree over, so this side here, over this side here, so the tree over the person is equal to the tree shadow over the person's shadow. Okay, now this would be fine, but if I want to go one step further, I could say this here and this here. So I can say the tree times the person's shadow equals the person times the tree's shadow. And if I want to find just the height of the tree, I could divide both sides by the person's shadow. So I would get the tree equals the person times the tree's shadow over the person's shadow. And this would be my final answer.